In today's lesson titled Geometric and Arithmetic Sequences and Series, your objective is you'll be able to compare and contrast properties of geometric and arithmetic sequences, and we'll be able to calculate the sum of both. So, before we start, let's make sure we know what a geometric and arithmetic series or sequence is. So, let's start with the idea of a sequence. A sequence is simply a list of numbers in order. And below right here, 3, 12, 48, 192, 7, 68. This is an example of a geometric sequence. We can transform a sequence into a series simply by adding addition signs. So the definition of a series, it's the sum of a sequence. On the right side here, I have an arithmetic sequence, same definition, and an arithmetic series. So right now, what do you notice about the difference between these two? Well, the main difference is the way I get from term to term in a geometric series or sequence is I have to multiply, whereas the way I get from a term to term in an arithmetic series or sequence is I have to add. And that's a key concept here. The key concept is to move from one term to another. In a geometric series or sequence, we multiply, and for arithmetic series or sequence, we add or subtract. Now, they both have general forms. The general form for a geometric series is u plus u plus r, u plus u times r, plus u times r squared, plus u times r cubed. And you'll notice here what's changing is we're simply multiplying by r each time. Whereas for an arithmetic series, instead, we are going to add what we call the common difference. In this case, is d. And we're going to add d, then 2d, then it would be 3d, so on and so forth, till you get the final term. Each of these terms we'll label as u subscript 1, u subscript 2, u subscript 3, so on and so forth. And that just is a way for us to label which term we're working with. And below, I'm going to show you all the different variables in each of these. So u subscript 1 is our first term in both. U subscript n is our nth term, so whatever term we're talking about, our nth term. The r in a geometric series is the common ratio or growth factor. That's what you multiply by, whereas the d in an arithmetic series or sequence is what we add or subtract. And then in both cases, the n represents the number of terms. So, to move on, I've kind of summarized this information right here on the top for our geometric and arithmetic series and sequences. Now we have a few formulas, and the first formula that I'm going to show you for each is going to be how we solve for a specific term, and then the second will be the sum. So if I'm trying to find the specific term in a geometric series or sequence, the formula is u subscript n is equal to the first term, u subscript 1, times our common ratio r raised to the n minus 1 power. This is if we were trying to find, for example, the 10th term in a geometric series. If we're trying to find the sum of a geometric series, we use the following formula. S subscript m, which represents the sum of however many terms we want to find, and that's equal to the first term times our common ratio raised to the n power minus 1 divided by our common ratio minus 1. We can also reorganize this formula as I've shown below. That's why I put the or there. We're simply just reorganizing what we have in our parentheses. So instead of subtracting 1, we're going to subtract our common ratios here. Both are totally fine to use. For our arithmetic series and sequence, to find a specific term, we use the following formula. U subscript n is equal to our first term plus n minus 1 times whatever our common difference is. To find the sum, it's s subscript n, the exact same variable we use for geometric, and it's equal to our n, our number of terms, times u1 plus un divided by 2. And what you'll notice in this particular formula is it's really just the number of terms times the average of the first and the last term. So the n is the number of terms, and then this right here, adding the first and last term and dividing by 2, is really just the average of the first and last term. Now sometimes we won't have our last term, and when we don't have our last term, we have another formula here, and this formula simply gets rid of the u subscript n and instead replaces it with the formula we used to find that. So in this case, if you don't have u subscript n but instead know the common difference in our first term, we can still find the sum of the series. From here, we're ready to move on to some practice problems. So let's take a look at our first practice problem. So in this problem, it says that a teacher earns an annual salary of 45,000 US dollars for the first year of her employment. Her annual salary increases by 1750 each year. So the first part of the question says calculate the annual salary of the fifth year of her employment. And we're looking just for the annual salary, not the total amount she makes. So the first thing you should notice when you look at this problem is that it's arithmetic. And the reason why it's arithmetic is it's increasing by the same amount each time, $1,750. We're not multiplying by anything, we're simply adding. So that makes the problem a little easier because usually arithmetic series or sequences are a little more straightforward. Now in this first problem, part A, the question's asking you to calculate her annual salary in the fifth year. So we're really just finding a specific term, the fifth term. So we're going to use this top formula right here to solve for problem A. And what we're going to do is we're going to say U subscript 5, our fifth salary year, is equal to our first salary year, 45,000, plus our n minus 1, which is 5 minus 1, times our common difference, which in this case is $1,750. All you got to do is type this into your calculator, make sure you're using the appropriate order of operations, and you find out that in the fifth year she earns $50,800. Now, moving on to the second question says she remains in employment for 10 years. Calculate the total salary she earns during the 10 years. And this word total is a clear giveaway that instead of using the formula to find a specific term, we're now going to use one of our sum formulas. Now, we have to decide which one to use. And you'll notice the first one uses U subscript n, and the second one does not. And in this case, since we're finding our value for all 10 years and we don't know U subscript 10, we're better off using the second formula because we have all the appropriate information. So to solve for B, we're going to do S subscript 10, so the sum of the 10 years is equal to n, which is 10, times, in parentheses, 45,000 plus 10 minus 1, which is 9, times 1,750 divided by 2. Again, all we have to do here is substitute this information into a calculator, and you'll find out that after 10 years, she'll have made $303,750. So now that we've gone over an arithmetic problem, let's move on to a geometric problem. So in this problem, it states that the seventh term, U7, of a geometric sequence is 108. The eighth term, U subscript 8, of the sequence is 36. So the first thing I'm going to notice here is we're clearly dealing with a geometric sequence. Therefore, we are going to use any of these three formulas. This is our specific term formula, and these are our sum formulas. Now the first question says write down the common ratio of the sequence. And I'm going to immediately note that if the seventh term is 108 and the eighth term is 36, we're clearly multiplying by something that's causing our numbers to go down. So that means we're going to be multiplying by a fraction or a decimal. So using the logic of a series or sequence, I would say that 108 times some number, and that's our common ratio, gets us 36. And what is that number? Well, if we want to use inverse operations, we could divide by 108 on both sides, and you'd find out that our common ratio R is 0.3 repeating, or 1/3. So really what's happening is we're dividing by 3 each time to get our next term. Now that we've found our R, the next question says find U subscript 1, our first term. Well, the easiest formula to find the first term is going to be this first one right here. U subscript n equals U subscript 1 R to the n minus 1. Now, we know some terms in our sequence. We know the seventh term and we know the eighth term. So we can use either of these values to solve for our first term. So I'm going to use the first one they gave us, our seventh term, and I'm going to substitute it in the formula. So I know that U subscript 7 is equal to U subscript 1 times 1/3 our common ratio raised to the 7 minus 1 power, because we're going to the seventh term in this case. The nice thing is we know our U subscript 7, we know our seventh term, and it's 108, which is equal to U subscript 1 1/3 to the sixth power. From here, I'm going to evaluate this exponential expression right here. So now I have 108 equals U subscript 1, our first term, times 0.00137. And then the last thing I'm going to do is divide both sides by 0.00137, and you find out the first term is 78,732. So we've solved part B. The last piece says the sum of the first k terms in a sequence is 118,096. Find the value of k being the total number of terms. Now, if we want to do this algebraically, we need to use one of our sum formulas. And we'd substitute and find that the sum, 118,096, is equal to our first term, 78,732, times, and I use the second formula here, 1 minus 1/3 to the k, divided by 1 minus 1/3. You'll notice there's only one missing variable here, and that's the variable we're looking for, k, which is the total number of terms. However, since that variable is in the exponent, if you recall from Algebra 2, this particular function will require logarithms. Now, if you're comfortable with logarithms, by all means, solve it that way. However, there is an easier way to solve this, and it's simply to list out the terms until we arrive at the sum that we're looking for. So you would find out that when we list out our terms in our series, starting with our first term, 78,732, and simply dividing by 3 each time, you find out that after 10 terms, we arrive at the sum 118,096, leaving us with our final answer, which is that k equals 10, because after 10 terms, the sum of our series equals 118,096. I hope that was clear. There was a lot of information there. Good luck on your work.